Day 19 is a lot of fun. It's the most interesting parsing that we've seen so far. And we're parsing this sort of interpreter-like language, and then we're parsing the inputs, and then we're running each input through this little interpreter machine, which consists of labels, so we start it in, and then conditions and instructions. So this says if s is less than 1351, go to px. And then px is if a is less than this, go to QKQ, otherwise go this, and then you continue until you get to an A or an R for accept or reject. And we have to find all the parts, these are our parts, that get accepted. So this is it's a lot to parse. So what we're gonna do is say I wanna parse instructions or rules maybe, and then I wanna parse new line, and then inputs. But what I want to do for rules is what I usually do, which is like split on new lines and parse a rule. Just for now, I'll put a dummy thing for each of these. Split on new line, parse input, and an input will also just be 0. But this isn't going to work, as you can see. And it's not going to work because rules, this split is going to split on new lines the entire input, and then it's going to try to parse every single line as a rule. And it's not going to like get to this. So what I actually want to do is say, okay, parse rules, but restrict what it can see. So sub parses only a substring of the input, and I want to restrict it just until we get to this empty line, this blank line. And that worked. I can like capture the first letter just to see that it did anything. But I once again like wish that I could just write like match everything up until this and then skip it when you're done, but I can't. I have to do it in these 2 steps like this. So what is an actual rule? So a rule consists of a label and then curly brace. And then I'm going to be a little more paranoid than I usually am to make sure that I like get all of the things and I'm not missing anything just because this problem has so much complicated parsing. So I'm going to explicitly assert yes, and we reached the end of the line. The end of the input, and our input is restricted to just the current line by this. So this is going to be all these instructions, I guess. And instructions, just to like debug this, I'll just say match everything up to the close brace. I need to define what a label is, and a label is accumulate one or more character in this set, range A to Z. And I only want to parse lowercase letters because I don't want to parse capital A or R as a label. I want to make sure that that's distinct. That will come in handy. When I parse labels here, I can just reuse the same peg. Let's see what I messed up. Actually, that looks okay. Label is I need to still capture each of these. Great. So what this says is take everything that matches, and so I could just say capture this, actually. That works identically. In my head, I want accumulate to like take all of the captures, but I don't need to do that. If I had done it this other way, where I capture each character multiple times, and I get this list of characters, and then you have to accumulate them into a single string. But by just capturing the outside of the sum, we capture all of the inputs. So, a digression that you did not care about. Okay, so each rule, I want to group it so that they're together. Okay, and I can see that right now I'm just parsing the label and then the whole input string. So let's parse instructions. And let's actually now do something that I haven't done yet, which is let's break this into some. I feel like once we start parsing inputs, it's gonna be like nice to keep these kind of separate. So I'm gonna do that, and instructions is actually, I'm gonna once again do the trick of restricting this so that I can just split on commas. And this will be an instruction. And an instruction, I'm gonna just make these nested just so it's a little bit easier for me to follow, because it's kind of complicated. An instruction is either a command, or a condition followed by a colon followed by a command. And a condition is a field, a field followed by an operator. Yeah. A field followed by an operator. And a field is, I'm just going to say that it's one character that we capture. I'll go back and fix this. And an operator is either a less than or a greater than. And for now, I'll just capture it as a string, but I'll probably want to change that. Okay, so a condition followed by a command, or just a command. So just a command would be one of a, r, or a label. And what have I forgotten or messed up? I screwed up the sub2 thing, didn't I? Yeah. Okay. And I want to group the instructions when I parse them. And I didn't capture enough here, I think. Because that's not right. What am I saying? AMRFG. I'm seeing the labels, AMRFG, but I'm not seeing the conditions aren't capturing anything, which is kind of funny. Capture this or capture that. And it's not doing it. We're never like getting this condition firing. The field is X, M, A, or S. Yeah, I don't know why it's not capturing these as well. Which means I've screwed up my parser already. So we enter here, we enter at main, and we parse the condition, and then a colon, and then the command. Which means we parse the field, and then an operator. And then a command. It's like I'm not actually capturing the condition, but I am parsing it because, yeah. So what's happening here is I think I've messed up my make sure this is exhaustive, and it's parsing a little bit. It's parsing, so this is failing. It's coming down to command. Command is matching the field X, M, A, and S as if it were a label, which it's not. So it's getting confused, and it thinks that this is like a go-to. So my condition is bad. So here's an example of an input, right? Of course it is. I forgot to actually put the threshold. So the threshold is just our old friend number. Okay, it's a little bit better. But let's make sense of this. We've parsed all of these bits and pieces, but it's not in a very good format. It's not a good representation. So let's turn it into a better representation. So we'll take a condition followed by a command. I'll call this a conditional or a command. And a conditional will parse condition, parse command, but then I want to reshape it a little bit. So I'll pass a function to apply when this matches, and I'll say if, and then this is going to parse kind of in order. I parsed the field, the operator, the threshold. So I want the operator, field, the threshold, and then the command. So that gives me if less than a 2006, then that. And I want to make sense of each of these. So label, I don't want to just be label. I want it to be labeled as go to the label. Go to the label. So that's like what a command will be as a go to. That's really what that means. This, instead of just being a, this will be accept. This will be reject. Okay, pretty good. And I'm actually gonna just, because I just don't want strings anywhere, I'm gonna call this less than, and I'm gonna call this greater than. So if, and then this kind of condition, which maybe I want grouped just for ease of reading. I don't know. Undecided. So I think this looks pretty good. And then I think it also makes sense for this whole thing to just be a struct. So instead of grouping this like I did here, what I'm actually going to do is take the whole thing and run it through the function struct. And that will give me, yeah, so let's maybe change the output order because now we're seeing it in the order that the struct represents it. Or we're actually not. We're seeing it in a stable sorted order. That's like a nice thing that Judge does that I forgot. So we're seeing the keys in sorted order. And each key is a list of things to do. And we're going to evaluate the conditions basically until we get to accept or reject. And I think that's all I need to do. I think that's all I need to do. So let's move on to inputs. So input, this is, we can actually, I'm just going to copy this down here so I can have it next to me. So I'm going to do something lazy, which is I happen to know that the input always just parses it in this order. So instead of parsing this as an actual map or hash table, I'm just going to parse this as a tuple of 4 values. So this is going to be, I actually maybe don't even need to group this. But it's going to be a field, which I guess I can break this into a shared rule. It's going to be a field followed by an equal sign, or yeah, I'm actually going to do this really dumb. I'm going to say x equals, and then call this an int, followed by a comma, m equals an int, comma a equals int, comma s equals int, close bracket, end of input. And then I'm just gonna take that whole thing and turn it into a tuple. So actually pretty simple. We could parse this as an actual like list of key value pairs, but I think it's actually going to be easier if we work with this as a tuple, so I don't need field to be split out like that. And this failed because int is not a thing, but I'm going to make it one. Now I will group the inputs. So now I should have captured two things, the rules and the inputs. And here I captured these as strings though, and I don't like that. What I'm actually going to do is turn each of these strings into indices. So I'm just going to say like x is 0, m is 1, a is 2, and s is 3. So nil. I didn't capture it. I had nothing to look up in the map. I passed it. So greater than 0 to 662. So we'll just have to remember that we mean like field 0, field 2, field 1 when we actually implement the solver. So let's do that now. So simulate, we'll take rules, and this will be our rule map of just all of the rules, this big struct that we parsed. And I want to say like the current instructions. So I'll call it instructions. And I should probably have the input as well. That seems important. So input rule instructions. And instructions is going to be like what we do next. And once again, I'm going to be using linked lists. So I'm going to take the instructions that we have and turn them into linked lists of the instructions. And this way I can, like as something matches or doesn't match, I can just recurse on the tail of the non-matching input. Or if something does match, I can just call the function looking up the instructions. But this way, like, we're just kind of cootering through this linked list. So I should actually turn all of these into linked lists, and I don't know exactly how I want to do that. But let's say that def rules, and like I like matching it like this. But maybe I should just go ahead and instead of grouping the instructions, group the instructions and say to linked list as my function. So I think it's a little bit harder to read when I look at the test output here, but I know that it is the linked list representation of the same list. So that's the easiest thing probably. So def rules, and what I'm going to do is I'm going to simulate. I'll just do this for, I'll do it as a seek for input in inputs. Yes, I'm shadowing input, don't worry about it. Means something totally different now. I'm going to simulate that input with the rule called in, which is where we start as our instructions, and I'll pass it the whole rules dictionary so it knows how to look up go-tos correctly. And if we test solve that on our test input, we get a bunch of nils because simulate just returns nil. So that's fine. What do I want simulate to return? I want it probably to return a Boolean, true or false, or if the input matches. So seek is not seek is still fine. So return all of the inputs that match the simulate. Right now nothing matches, which is good. Okay, and that's just fine. So I'm going to use pat again. I've already imported it. And I'm going to match the instructions. And remember that this is a linked list, so in my representation, like this is the next instruction. So if we have to accept, then it doesn't matter what's next. Instructions is always going to be 2-element tuple of the head and the tail. So if we have to accept, then yes, the input gets unconditionally accepted. And if we have to reject, the input gets unconditionally rejected as our next instruction. If we have to go to some label, then I'm going to simulate the input with the same rules, but now this is going to be in rules label as the new instructions that we're going to match over, and I'll just return that. And then here is where it gets interesting. If we have an if, which, whoops, I don't care about the rest of the instructions if I reach a goto. Anything that happens afterwards doesn't matter. So this will be if I'll call this like remaining instructions. So if we have an if, and I did put a bracket in here, so it'll be less than field value. I'll just call this condition, and I'll just say then. I'll call this else. And input and condition, just to like separate this out. I'll say pat match condition. If it's a less than field value, I'll say in input field less than value. If it's a greater than, I'll say greater than. I could have done that slightly smarter, just match the actual function instead of this operator, I guess. Be kind of a smarter way to do it, but I'm not going to change that right now because in part 2 this representation will be actually slightly nicer. So I'm going to say if we evaluate the condition on our input, then simulate the then branch, whatever those instructions might be. Otherwise, simulate the else branch, which is the, keep going to the remaining instructions. And does that do anything? Go to QS did not match. So what's happening here is Pat is complaining because my pattern didn't match on line 85, so this pat match. So we're matching instructions, and we somehow got just this go to and nothing else. There was no like, it wasn't wrapped in a linked list the way that it should be, which makes sense because the then case here is not a linked list. This is a single instruction. So I want to say like linked list singleton of the then rules. So kind of inelegant, but of x is x and then. Okay, so that actually seems to have done something. So I got these 3 parts that matched. And I'm going to go and look at how many parts should have matched. 3 parts should have matched. The 787, the 2036, and the 2127. Great. So it looks like that worked. And the answer that it wants is actually our old friend sum loop of the sum of each of the numbers. Total of, so I want that. So sum loop the input and the inputs when it matches. We'll call it the field in the input. And I want to sum all the fields. 19114, which was the correct answer. And just to double check, also worked there. Okay, so let's move on to part two. Part two is fun, I think, and you'll see why I wrote this in this recursive, like tail call style instead of just like a state machine where we have some state and we update our state as we go through, because for part two, we're going to have a different simulation and a different concept of what input means. So we actually don't care about the inputs anymore, I think. We're just going to ignore the inputs, and we're going to simulate this with something a little bit different. So our initial input, I should probably describe the problem. So we're basically going to say, find all of the parts that would be accepted. Like find literally every part that could be accepted. And what we're going to do in order to do that, we can't just search everything exhaustively. Oh, and a part is the valid range of parts is like x equals this, m equals that, a equals that, and s equals that. So the like there is a finite number of them, but it's, you know, a really big number, and we're not going to simulate every one of those. So instead what we're going to do is have our input be a range. And we worked with ranges in part 5, and we're going to still, I'm going to reuse, I moved it into my little util module, all of the range functions that we wrote back in part 5, and I'm going to try to use them for this. I actually didn't do this when I solved it originally, but I think I should have, and it's obvious that it kind of wants you to, but I didn't make quite as nice of a range helper the first time I did part 5, so I didn't have a nice thing to use the first time I did part 19. So let's talk about the initial input. So the initial input is, I made these functions to create ranges, so of start end, but the way that this works is end has to be 1 greater than the actual end. So because my ranges are like half open, where the start is inclusive and the end is exclusive. So of start end is actually maybe not the right way to do this, but 1 is the start and 4001 is the end, because it can be 1 to 4000 inclusive, which actually happens to be the range represented by a start of 1 and a length of 4000. So I'm going to just construct these ranges directly, just knowing what their actual internal representation is. So that's our initial input. And I'm going to run this simulation over my initial input. But now the simulate is going to be able to accept and return multiple things. So there's a few different ways that we could handle this. I think what I want to do is say, so for each part in the accepted parts, so I'm going to have this return the parts that it accepts, which are going to be like part ranges, actually. And for now, let's just take a look at them. And it expected an interval type, and it got true, which is what we expected to happen, so I haven't actually implemented this yet. And what I'm going to do, there's lots of ways that we could deal with accepting. We could just have this be a callback. We could have this like pass some accepted array and just have it like pinned onto it. But I'm going to try doing this as a coroutine. So I'm going to like basically write it as a generator. and it's going to generate, it's going to yield a part every time it accepts it. So when we reach accept, I'm going to say yield the input. And if you reject, just stop. Don't do anything. Don't keep going. Just you're done, and it ends. So we're going to run this, and every time we call yield, we're going to yield a value to this coroutine, this fiber that corow creates, and then we're going to iterate over it as a part. And let's see what works so far. Great. I don't really know why that exactly worked, but I'll buy it. I guess evaluate condition is doing some weird stuff because it's comparing labels and it's not really supposed to. So everything else is actually correct-ish. The difference now is that we don't evaluate the condition. Really what the condition is going to do is refine our input. So if we say like x is less than 2000, then if our input starts like this, now our input should look like this. We're going to like have this list of ranges and we're going to restrict each range every time we hit a less than. But that's not sufficient because we also need to say, well, what happens if you don't restrict the input? Like, what if the condition doesn't match? So we're going to simulate kind of the range that could match and the range that can't match, and they're going to go their separate ways. So we're gonna fork, and I'm going to say we'll just call the simulate function twice, and the simulate function no longer returns anything; it's just yielding things. So this is just a do, and we're going to perform these two side effects. So simulate. This is basically going to be like matching, so from the input that we have now and the condition, the matching things, and then the not matching things from the input and the condition. So what are the things that match? I'm going to take my I'll just go ahead and define not matching input condition, and this is going to say, like, I don't know, just return nil. This is all full of type errors. I just want it to compile. Good. So given this input and this condition, what are the new inputs that could match? So if we have less than field, what I want to do is turn this condition into a range. So condition to, like, I don't know, input's weird. Condition to ranges? Sure. So what I'm going to do here is say less than field value. This matches the range. Starts at 1, it always starts at 1. And it matches the range from 1 to 1 minus value. Or in other words, it matches exactly value things because it's 1 indexed. If we're greater than, then I want to match, it doesn't really matter. I'm just going to say start at 1 plus value, and then get all the way up to, I'll just say it's 4,000 long. And I'm only going to be like intersecting and subtracting, never like unioning ranges. So this will work to restrict it. Even though this is like an overestimate, really this should be like minus 4,000 value or something is the actual length of it, but I don't want to think about that. So let's test this condition to ranges. And this should actually be like, I don't know, at field is a dumb thing to say, but at field, field. So define at field. This will be our index and our x. and we'll say I'll call this maybe everything instead of our initial input. We'll start with everything. Oops. We'll start with everything. And then I'm going to set one field in everything. And I don't think there's like a tuple set, is there? Let's look at the API. Tuple, no, that's totally different. I basically want to say like set index or with index everything ix, and with index we'll take an index value, an I, a value, and we'll just say, I don't know, it's goofy, but I'll just say I want this to be like kind of efficient, so I'll say I'm just going to specialize this to our 4-element tuples that we have now. So case, well, even that doesn't really work very well. There's no like functional, or is there a functional update? Update in. So I don't actually think that these work with a immutable data structure. So I'm going to do something really dumb. I think it's of tuple is the name of it. Array. So I'm going to take this thing, convert it into an array, and then put the array, and then I'm going to return it as a tuple. Is it array of tuple, or is it tuple slice, or array slice test with index? So this will be like 1, 2, 3, index 0, I want to become 10. It's not array of tuple. Just say array slice, maybe? A word I cannot type. Great. Condition to ranges. So that worked. Converting it to an array, mutating it, converting it back to a tuple. This is so inefficient, but I don't actually know the right like arbitrary replace thing. But okay, condition to ranges. Oh yeah, we gotta test this. So given everything, given the condition that we have 0 less than 2000 was a decent condition that I proposed. It looks like that did the right thing. And let's do this. Let's say, what if it's greater than 2000? Then the range is from 2001 up to a big thing. And that's, yeah, that's fine because all we're going to do is be intersecting these. So let's write these. Intersect ranges. And this is going to be A and B. And I basically want to map range intersect over A and B. This is like a zip, remember, when we pass multiple arguments, so zipping them. But map, infuriatingly, returns an array always, but I just want to be working in tuples. It doesn't really matter, but these things are immutable. We're doing this all immutably. And let's just check if that worked. Intersect ranges. Let's give it like, let's construct these in kind of a cute way. So I want to say the first range will be 0 is less than 2000. The second range will be 1 greater than 2000. And when we intersect them, we get something that reflects the minimum of both of them. That's correct. And yeah, okay, so I can see here that this became length 2000 because, yeah, because we intersected it with the 4000. So that's what I expect. These all like go to the right places. So similarly to intersect ranges, we also want subtract ranges, and this will be range subtract. But here, remember, when you subtract two ranges, you get a list back. You get an array of 0, 1, or 2 things that could match. And that's not actually what we want. And I happen to know that from the way that we're going to be using this input and these puzzles, we're only going to be subtracting things such that we can only ever have one result back. So I'm going to just call this like exin or bang or something, or just not worry about it too hard. So the function that I actually want to use is like range subtract 1 or none, I'll say. And A and B, and this will be range subtract A and B. What I'm going to do is I'm going to match, pat match this against, if I got nothing back, that's fine, that'll be nil. If I got exactly one thing back, that's great. And if I got everything else, I want to sorry, error. Like subtraction produced multiple results. And this could happen, of course, but not given the way that I'm going to call these functions. So given these, I actually want to say define reconstruct ranges. So remember that this could return nil if the ranges don't intersect. And when that happens, I don't want something that is like nil 1 4000. I want to make sure that these are always like valid. So reconstruct range will say if any of these are nil, I think the function is any. If any nil in the range, then nil for the whole thing. Otherwise, tuple slice the range. And let's test that. Reconstruct ranges with 1 and 400, sure, nil, 1000. It's not any. It's every or some or all. Some nil. Some, great. So if anything in this is nil, throw it away entirely, otherwise you get this. And now, I'm just gonna check if you say simulate with a nil input, I'll just do nothing. Or unless nil input, do this pat match. Otherwise, you're done, there's nothing to do. So this way I don't have to check both of these times that matching and not matching returned non-nil values. Okay, gosh. We're on a little bit of a tangent here. I still need to implement matching and not matching. So matching, we have these helpers to do conditioned ranges and then to do these sort of arithmetic on lists of ranges. So the things that match are going to be condition to ranges of condition, and then I called it intersect ranges condition of the input, and then not matching is going to be just subtract ranges. And let's just test that. So matching, my input will be 1 and 4,000. I'll just pretend like there's only one field. My condition will be less than, actually, let's have it start at like 100 and be length 200. And I only want things that are less than 150. So what could match? I just gave that too many arguments for some reason. Where do I call it? Yeah, that was goofy. Yeah, I guess I don't know. I don't know what I was thinking there. Okay, so the matching subrange, given the condition that things are less than 150, is in fact that. And what about the condition that things are less than 100? That would give me... Ooh, so I think I have a bug here. I think I did something wrong with my less thans or something. So what is the condition to range if you're 2000, if you're less than 2000, there's actually, is that right? How many values are there between 1 and, there's, yeah, okay. Yeah, less than, okay. I think that's right, okay. I'm glad I tested this. These are our off by 1 errors that we can get, and if I'm less than 101, that gives me the length 1. Okay, so there's 50 things that are greater than or equal to 100 and less than, okay, this is all right. Okay, and let's do the same thing for not matching. So what do we expect? If you're less than 150, all the things that do match this range, so this is 100 to 299, inclusive on both ends, and the things that are not less than 150 are 150 to 299. Okay, so that worked. Let's try running this. So I'm allowing like a nil through somewhere, I think. Which is matching and not matching. Oh, look. Matching gave me the list nil, which is not what I wanted. Why did it do that? I called intersect ranges, and I gave it something that shouldn't intersect. Oh, because I never called my reconstruct ranges function. I'm still just calling slice. Okay, and now I can see that yes, I'm getting nil, not the array that contains nil. And let's just make sure, what if I'm testing something that is less than 200? Sorry. What doesn't match that's less than 300? Nothing. Then everything matches. Good. So now, having done this for my test input, this is the only range of parts that could match. Is that consistent with what it tells me the answer should be? So the number that I'm going to have is the number of distinct combinations. So the distinct combinations are something like the length of each range, I think. Is that right? So for each part and part, for each range and part, I want to take the range length of the range. And actually, this isn't a sum loop, it's a product loop. So I can write this as a fold loop where we multiply starting at 1. So for each part and part, for each range and part, sorry, we do want to add these all up if there's more than one. It is a sum loop, but we're taking the product of mapping the length over the ranges, I think. Screwed it up. We got range length. So what is this part giving me again? So that's the part, and that's the range, and why doesn't range length work? Because, oh, right. I don't want to do this as a nested loop. Okay, sorry. That's a really big number, but it's not the right really big number. I see what I did wrong. I'm subtracting like this is actually not the right range. When I say condition to ranges, it doesn't give me the inverse condition properly. So I do want to do this subtraction, but I only want to subtract like the one field that mattered. So actually, that is probably where my I don't want it to refine starting from, say, and then this just becomes with index. Starting from field, we don't need this at field thing anymore. So when I'm doing the matching, I want to start from everything. Oops. When I'm doing the condition to ranges, I want to start with everything. When I'm matching, this should be everything. When I'm not matching, this should be nothing as my starting point. So my everything is this, and my nothing will just be, say, 0, 0 every time. Okay. Great. So I put in some debug output to understand what's going on. And here I can see this is my test case using test standard out. Turn that back to just a test. I can see that I'm matching both of the ranges that I wanted to be matching. And now we can turn this back into a sum loop and take the product to get the actually correct answer. And then let's see how long this takes on the real input. Cool. So that was a long and embarrassing diversion, not thinking about my identities and making sure that the not matching is what I get for using this just single thing here, because I ended up, I would have caught this bug if I had used a more realistic example. Oh well, that didn't take that long. You didn't have to watch anyway. This is probably the last day that I'm going to work through in a video like this. I want to talk about a couple more of the solutions, but I don't think that the actual writing of the code is going to be that interesting. So this might have been the last time you watch me struggle to solve an admin of code problem that I've already solved in the past.